In this video, I will show you how to graph trig functions. For example, this sine function, and then I will show you how to graph this tangent function. And hopefully that will give you an idea of how to graph all of the different kinds of trig functions. So let's see. Based on the a value of 2, that tells me that the amplitude is going to be 2. I'll come back to that later. Even if this had been a -2, for the amplitude I would have said +2. Now, for the period, the period is very closely related to the b value. And this is the b value right here. Okay, there's my b value. And it turns out that the period is going to be the normal period, which for sine is 2 pi. For tangent, it would be pi. But 2 pi divided by the b value. That's how you get the period. So that's why the period is going to be 2 pi divided by 3 in this case. So the period is simply 2 pi over 3. Now for the phase shift, you actually have to factor out the b value. You cannot look at it in this form. So I need to rewrite this a little bit. So if I rewrite this, I've got y equals 2 times the sine of, so I'm going to take that 3 outside of parentheses. Okay, and when you take it outside, you need to divide by it. So I'm really dividing everything by 3 in order to do this. And when you divide a fraction by 3, you really just put the 3 in the denominator. That's how you divide a fraction by a number. So these 3's will cancel each other out. So I will just have x minus, and then here I will have pi over 6. Now, okay, this value, which is really, we call it the h value. I've got a, b, and then I've got h and k. This h value is really the phase shift. Okay, so that's why the phase shift is going to be pi over 6. Alright, if this had been x plus pi over 6 inside of there, then my phase shift would have been negative pi over 6 in that case. Alright, but it wasn't, but I just wanted to be clear that it's the opposite sign as this. Okay, so that's enough information to get us started. Okay, we're only going to do one period of the sine function, but we sine, cosine, and cosecant and secant, we only do one period. Tangent and cotangent, we do 2 periods of that. So we're only going to do one period. If there is a phase shift, then what you want to do is start with the phase shift. So that's why I'm going to start with pi over 6. So I'm going to just throw down my pi over 6. Now I'm going to count over 4 big spaces. So 1, 2, 3, 4. See, I moved 4 times. So that means every one of these jumps is 1/4 of a period. So that's why I need to know what 1/4 of the period is. So since the period is 2 pi over 3, how about what's a quarter period? Alright, a quarter period would be 2 pi over 3 divided by 4. So that's why I'm putting a 4 in the denominator. I'm dividing by 4. So that means that the quarter period is going to be 2 pi over 12. Which means that the quarter period is going to be pi over 6. That's going to make this a little bit easy if you ask me. Because the idea is to take your phase shift, your first x value, and then add a quarter period 4 times. So I need to take this pi over 6, and I need to add the quarter period of pi over 6. Alright, and normally I would need to get like denominators, but these are already like denominators. So like 1 pi over 6 plus 1 pi over 6, you can probably see that that's going to be 2 pi over 6. I'll reduce in a moment, because I'm not reducing yet because I want to keep adding pi over 6 over and over again. If I added another pi over 6, that would be 3 pi over 6. And then 4 pi over 6. And then 5 pi over 6. Alright, this is my quarter period, so I'm adding a quarter period again and again and again. So I've left myself space to reduce. Okay, because you always want to reduce for your final answer. So 2 pi over 6 will reduce down to pi over 3. This will reduce down to pi over 2. This will reduce down to 2 pi over 3. And this does not reduce, so I'll just put 5 pi over 6. Now it's important to see where the y-axis would go. Alright, so I'm going to make another jump or two. Alright, so here I was adding pi over 6. What about if I subtracted a quarter period? What if I did minus pi over 6? That will tell me what I would get next. But minus pi over 6 is 0, isn't it? That tells me that the y-axis is actually going to go right here. So I am going to go ahead and throw down my y-axis. Alright, I might need that later. Alright, so there's my y-axis. So I'm going to erase all this business and get it out of my way. Okay, so the hard part is over. Let's talk about the amplitude. The amplitude is 2. Okay, actually, first let's talk about the midline. You see that plus 1 on the end right there? I feel like I should clean this up a little bit. That plus 1, that tells me where the midline is going to be. That's my vertical shift. So everything is shifted up 1. So I definitely am going to need that. So this is my midline. So I'm going to go ahead and put a dotted line right here to show that this is my midline, people. Alright, but the amplitude is 2, which means I need to go up 2 from here. Okay, so like 1, 2. And I need to go down 2 from here. So 1, 2. So if I go up 2 from here, that's going to be 3. If I go down 2, that's going to be negative 1. Okay, so you know what? I'm going to go ahead and put some additional guidelines. Let's see. I think I'll use this color. I'm purposely using a light color. This is optional. The midline, you have to show it. Alright, you have to show the midline as a dotted line. I like to use an additional pair of guidelines for my max and min. So that's what I'm showing right now. Alright, but this is optional, people. Alright, you just have to decide how close to my level you want to be. Okay, so I think we are ready to go. So this is the sine function. We are going to begin at the phase shift. So we know that sine function begins on the midline, and then it rises from there, unless there's a reflection, and there's not. And then it falls back to the midline, and then it falls down to its low point, and then it rises back to the midline again. So these 5 dots are what I'll be grading, and they will guide you in your sketch, which should look something vaguely like this. Alright, so that is one period of this particular sine function. Alright, last we're going to graph this tangent function. But before we get started, a lot of students get confused between the tangent function and the cotangent function. So let me emphasize the difference between the two. So here's a quick sketch of just y equals tangent x. Alright, I'll put that on the left hand side. Then over here I'll do a quick sketch of y equals cotangent x. So in both cases, I'm gonna do one period. So I'm gonna have a beginning and end, and then I'm gonna cut that in half, then I'm gonna cut that in half. And I'm gonna do the same thing over here with my cotangent function. So my beginning and end, cut it into 4 pieces. Now, alright, this is the midline. So let's just say this is the midline. The tangent function begins and ends on the midline with an asymptote right in the middle of the period. By contrast, the cotangent function begins and ends with an asymptote with an intercept right on the midline. So these are opposites, all right? You have to have this in your mind. If you're going to graph a tangent function, your first point should be on the midline. So this should be like whatever the phase shift is, right? Like if the phase shift turns out to be pi over 3, for example, then there should be a dot at pi over 3. If you're doing cotangent, if the phase shift, again, imagine that the phase shift was pi over 3, then we're starting with an asymptote. So there should be an asymptote at pi over 3. Do not get these mixed up. Tangent starts with a point. Cotangent starts with an asymptote. Okay. I've just watched kids just mix those up back and oh, you know what? Can I bring that back? I wanted to say one more thing. Oh no. Okay, you know what? I need to bring my tangent graph back. Hold on. There's one more thing I wanted to say before I erased my tangent function. Okay. Tangent is always increasing. Alright, so this graph would be increasing like this and increasing like that. Tangent is always increasing. Unless there's a reflection, in which case it will be decreasing. Cotangent is always decreasing. So cotangent would be looking like this. Okay? Unless there's a reflection, in which it would be increasing. Alright, so keep that in mind. Alright, I think before we even get started, I would like to factor out the 1/2. So this would be the same thing as y is equal to -3 times. And I'm going to bring this 1/2 outside of parentheses. Okay? And the way I can bring that 1/2 outside is by dividing everything by 1/2. So I'm going to have x here. Alright, x plus. So the question is, how do I do pi over 6 divided by 1/2? Well, you multiply by the reciprocal. So you do pi over 6 times 2 over 1. So that's 2 pi over 6, which is pi over 3. So in here I should have x plus pi over 3. And that's going to tell me the phase shift in a moment. But let me not get ahead of myself. Okay. The period. The period is going to be 2 pi. Whoa! That's false. For tangent and cotangent, the natural period is pi. So I'm not going to do 2 pi over b. I'm going to do pi over b for tangent or cotangent. For all of the other trig functions, it's 2 pi. Alright, so the period should be pi over b. The b value is right here. This is the b value. The b value is 1/2. This is the a value. So that would be pi over 1/2 Alright, but then you multiply by the reciprocal. So the period is going to be pi times 2, which of course is 2 pi. So the period is 2 pi. Bam! The phase shift is going to be the opposite of this. So the phase shift is going to be negative pi over 3. Okay, vertical asymptotes. I don't want to list this. Having these little spaces here makes it look like I want to list. I want an equation for all of the asymptotes, so we'll talk about that in a moment. But let's get our graph going, shall we? So, okay, I want to leave myself space for 2 periods of the tangent function. So whenever there's a phase shift, I'm going to start with a phase shift. Okay, so I'm going to put my negative pi over 3 right here. And I'm going to do 1 period to the right, and I'll do 1 period to the left, and that'll be my 2 periods. So here I go. 1, 2, 3, 4. Alright, that'll be my 1 period to the right. And then I'll do my 1 period to the left. So 1, 2, 3, 4. That'll be my 1 period to the left. Alright, but never forget that this is my phase shift. This is where I'm starting from. So let's see. Every one of these marks represents a quarter period away from the phase shift. So if I want to label these x values, I need to take my phase shift and add a quarter of a period. So I'm going to need to know what the quarter period is. So I'll call my quarter period QP. The quarter period is going to be the period divided by 4. So that quarter period is going to be pi over 2. So for that reason, I need to take this negative pi over 3 and I need to add pi over 2. Okay, I need to add the quarter period. In order to do that, though, I'm going to need like denominators. Okay, so I'm going to turn these both into 6's. So I'll multiply this numerator and denominator by 3, and then I'll multiply this numerator and denominator by 2. So that is going to give me negative 2 pi over 6 plus 3 pi over 6. Okay, and that should give me my next value. Alright, so now I'm just going to clear this out so I have a little bit of space. Alright, come on. Okay, so that would give me 1 pi over 6. Alright, I'm going to put a little bit low for right now. So I've got 1 pi over 6. Now I'm going to keep adding positive 3 pi over 6 again and again and again. So now I have 1 pi over 6 plus 3 pi over 6. That would be 4 pi over 6. Plus 3 pi over 6 again would be 7 pi over 6. Plus 3 pi over 6 again would be 10 pi over 6. Now I put it down low in case I needed to reduce something. So pi over 6 doesn't reduce, so this will just be pi over 6. 4 pi over 6 reduces down to 2 pi over 3. 7 pi over 6 does not reduce. 10 pi over 6 is 5 pi over 3. So in a moment, well, I might as well do it now. Hopefully I'll have better luck with the erasing than I did the last time I tried to erase. Okay, so that's how I get these values. Now, for the left-hand side of my graph, alright, the other period, instead of adding 3 pi over 6, I'm going to subtract 3 pi over 6. Alright, so again, I'm going to put my values far away for a minute. If I do negative 2 pi over 6 minus 3 pi over 6, that's going to be negative 5 pi over 6. Alright, if I do negative 3 pi over 6 again, that's going to be negative 8 pi over 6. Alright, negative 3 again, that would be negative 11 pi over 6. Negative 3 again, that would be negative 14 pi over 6. Alright, so now I'm just going to reduce that which can be reduced. Negative 5 pi over 6 does not reduce. Negative 8 pi over 6, that's negative 4 pi over 3. Negative 11 pi over 6 does not reduce. Negative 14 pi over 6 is negative 7 pi over 3. So in that way, I have 2 periods worth of x values. Alright, by adding a quarter period to the phase shift and subtracting as I go to the left. Now, okay, the midline is going to still be the x-axis. There's nothing being added on to the end, so I know that the midline is going to be the x-axis still. Now, before I get the y-axis involved, remember what I told you about the tangent function. Alright, the function y equals tangent x. If I have a period of that thing, okay, remember that it begins and ends on the midline with an asymptote down the middle. Alright, so that's what I'm about to do right now. So, my period begins with the phase shift, and it ends here at the final mark. So the tangent function begins and ends on the midline with a vertical asymptote right down the middle. Alright, now it's going to be the same thing going to the left. It begins and ends on the midline. Alright, so here's my beginning and ending with an asymptote right down the middle. Okay, I'm going to go ahead and move this quarter period business because it might be in my way. Now, I'm going to have to go ahead and get the y-axis in here so I can mark it with my amplitude and such. Well, technically it's not the amplitude for tangent, but the a value. So I see negative pi over 3, positive pi over 6. So I know the y-axis is going to be somewhere between these two numbers. So I'm going to go ahead and put my y-axis in. Because this a value of negative 3, that tells me that I'm going to have an important value up 3 and down 3. Okay, I don't have a ton of space here, but this would be negative 3 right here. And in fact, I think I will go ahead and put a dotted line to show these a values, kind of where they go. Alright, same thing down here. Okay. Now, so the a value for a tangent function, normally the tangent function is always increasing. So as I start at my phase shift, I would go upward as I go to the right. But see the negative sign in front? Because of that, it needs to be upside down. So instead of going upward, I'm going to go downward. So this function will be decreasing because it's upside down. Now when I go over one mark, I just said it had to go downward, but specifically it should be at this a value. So that's going to give me a swerve going. Oh man, I'm kind of missing. Let me try to recover. Okay, it's going to be kind of like that. All right, it got a little janky in there. Now, as I come to the other side of the asymptote, it has to be falling. All right, it still must be falling. So that means it's going to start from up high and it's going to come down. And at this mark, it should be at the A value. All right, so it should be doing something like this. All right, let me put an arrow on this. I'll put an arrow on that. So this is one period of the tangent function. So now I'll do my other period over here. And again, it should be falling. As it falls, it should be at the A value. So this should be looking like this. And it should be falling from here as well. As it falls, it should pass through the A value right here. So it should be looking like this. Alright, so there's two periods of your tangent function. Now let's talk about those vertical asymptotes. Vertical lines are always x equals something. So let's start with that. Now pick one of the two vertical asymptotes that you have graphed. I'm going to pick the 2 pi over 3. So I'm going to say x is equal to 2 pi over 3. And then I'm going to say plus. Now, I'm either going to be adding a full period or half of a period. So for the tangent and cotangent function, these asymptotes are one full period apart. You can tell because look at how many marks they are. 1, 2, 3, 4. 4 marks. Alright, that's a full period. So what was the period? 2 pi. So I'm just going to add a full period, and I'm going to put an n on there as a multiplier to represent the infinitely many. If I went another 2 pi and another 2 pi in either direction, I would hit all of the asymptotes. So if n is an integer, then this equation represents all of the vertical asymptotes for this graph. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.